I know they can hear us. They're typing, yep, and yes. I like it. I love it. And again, I'm going to turn this. I got to change it. Turn that focus on.
All right. Well, I know that you guys, when you went home last night, you probably, at dinner, your wife or husband or the kids or the dog or, probably had really, searching questions about the ontological structure. So, I mean, if I want to stop for a minute and answer any questions that they came up with, why, you can, or you can stop me anytime. Of course, my presentation style doesn't lend itself to answering questions in effect, but anytime you stop me, well, I'm happy to stop and answer whatever questions you have. I said yesterday, there's a lot of things I don't know. We only have a few decades, 3 or 4 decades working on this kind of thing, and we don't have 1,000 years of accumulated wisdom, so there's limitations on how much we know and how much we don't know. The world has a penchant for silver bullets, and they tend to be popular for a period of time, and then they'll be, it's over. But I don't think this is, when we first started working with enterprise architecture, it was perceived to be a silver bullet, So all you got to do is enterprise architecture. You'll never have to work or think again in your entire life. Everybody will live happily ever after, and you could get rid of all the programmers. So it was perceived to be a silver bullet, but it's not going to go away. It is, and one thing is the ontological structure isn't going to go away either. Someday I'm going to go away, but if I go away, if somebody doesn't pick it up, somebody else is going to discover it. Okay, that's all I did. I just saw the pattern. And, what, how, where, who, when, why, conceptual, logical, physical. I just saw the pattern, and then I told you guys the history of it, put enterprise names on it. It's not going to go away. And, somehow or other, the attention span of humanity, the technology has reduced our attention span to very, short periods. We worked with National University, which is in the out of San Diego area, but they wanted to put my material on, online, not online, but they wanted to make it digital, put it on CDs or whatever. And they said it had to be designed for 15-minute attention spans. 15. I did about 8 hours yesterday, geez. Nobody felt, no, you guys didn't fall off your chair. By the way, I wouldn't like to fly in an airplane that was designed by an engineer with a 15-minute attention span. So, I don't know what's going to happen here. We're on a collision course, I think. So I was with some people last week in a conference, and they were talking about this. And the technology has reduced attention span for a few generations now to minutes, not hours. But in any case, there's a lot of challenges out there that I don't exactly know how we're going to get through. But the point I'm making is that this is not going to go away. I actually think that I kind of stumbled across the equivalent of the periodic table. The periodic table didn't go away just because chemists' attention spans increase or decrease. It's still there. It's a natural classification. See, and I think what I happened to stumble across was the natural classification for communication purposes, a standard way to describe objects, whatever they happen to be. And I don't, even if you go into the manufacturing or architecture and construction industries, they may or may not be conscious of the ontological structure. I just happened to, by accident, to see people who, employed it, whether they were conscious about it or not. My architect friend, he was the one who basically, helped me understand he didn't talk about reification, but he talked about the owner's perspective, the concept, or his scoping, representation, the owner's perspective, the requirements from the perspective of the owner, and then the architect's design, in effect, which is row 3, then the contractor's plans, which is row 4, and the subcontractor's specification, instructions at row 5, and then the instantiation. He was the one who helped me understand that. So he didn't call it reification. It was somebody else later that said that. So anyway, I'm just saying I have a high level of confidence because this classification has been employed by humanity for thousands of years. And it's not going to go away. Okay, so and my framework, in a way, has been around for thousands of years. Whether they saw the juxtaposition of the two classifications, I just happened to see that by accident. So I'm confident about it. So and I've thought about the classification quite a bit. So I'd be happy to answer any questions. I said this to you guys yesterday. I'd be happy to answer any questions that you guys have. And I'm pretty careful to say, I don't know the answer to this one, but I think this is what, the way I would perceive it. And so any case, if you, you think about it at home or later, I don't care. You send me a note, send me an email message. Don't expect an answer that day, okay? I mean, within a week or two, maybe I'll get back to you. Like I got about 1 million email messages. I went back to the hotel and talking to Paul. I was really tired yesterday because I didn't have a lot of sleep, and then I didn't help last night either for a variety of reasons. I'm not going to bore you guys with my, I'm not going to have my tweet about what I was eating, and I said, when I heard about Twitter, I thought, who cares? I don't want to know about this. Life is too short, And in any case, now what I'm going to do, I have a few slides just to give you a little introduction to architecture modeling. Of course, going to pick up and do a little, a few modeling kind of exercises with you today. He gave you the homework last night, and and what if there's anything that requires a little practice, it's a practice recognizing when you see a primitive or not. And I was giving you the rules, but even if I tell you what the rules are, you have to work with them because you don't have an intuitive sense about them. I say, okay, if you have something that has a serial number on it, that's an inventory. You have to find the abstraction. Employee, yeah. Oh, you got a serial number, Paul. Yeah. Oh, you must be an employee. That's the inventory. You just have to begin to practice. That's pretty easy. If you have a process, anytime you have a verb, you have, the verb object definition or a naming convention for a transformation or a process is fairly straightforward. So when you're reading a document and say a verb, let me look at that one. Is that a process that I'm looking at? And does it have an object? It has to take an object because the verb in itself is so abstract it's meaningless. So. And then if you find you find names usually in a document, you'll find names of places, St. Louis or whatever, or Oregon. You find Oregon and say, well, that's obviously a geographic location. So is the facility on that location a branch office? Does it have a latitude and longitude? Yeah, okay, branch office. That's a storage place where something is stored, people typically, and, some raw material or something, and there's processing taking place there. So, what you have to practice, though that's not too hard, I mean, I tell you what the rules are for discovering them, but that's what needs practice because we don't do that typically, so. But it's not going to go away, and we just have to begin to work with the ideas. And Sunil, my friend from Bangalore, basically says, I think I said this yesterday. The first time you play golf, you don't play golf all that well either. In fact, the last time you played golf, you probably didn't play all that well either. My experience. but he's had to do something about 20 times before you get really good at it, you know. So that's the same kind of thing happens here. And Robin was talking this morning about, you know, having somebody else. There is strength in numbers, okay? If you have somebody else, we're talking about really complicated issues here, and some of the things are not obvious. And you'd like to have somebody to have some dialogue with, okay? To have somebody else working with you is good. Because there's so much resistance in our own domain, IT. So we don't want to do that. It takes too long. It costs too much. You know, we got to get some code here. You need somebody to be encouraging. Say, hey, wait a minute, we're not giving up. You know, forget them. You know, what do they know? So you know, you have to have some encouragement. That's a good idea too. So. All right, I'm going to give you a little introduction to architecture and modeling. I showed you yesterday some examples, but if, for example, you have a situation where the same word starts showing up in more than one column, does that word have the same meaning? Okay. And the answer is no, okay, because if a word employee, for example, shows up in column 1, well, that's a candidate for an inventory. You know, that would be an inventory. Do you inventory employees? Yeah. Do you put serial numbers on them? Yeah. You know, so that's for sure. You know, if it shows up in column 1, that's going to be an inventory. If it shows up in column 2, it's a noun, so it can't be a transformation, okay? So it has to be either an input or output to some kind of a process. But I'll show you this a little bit later. You're looking at a view of the employee here. You know, you're looking at some view of it. You're not looking at necessarily the employee, but something is, you're looking at a kind of a view of it. And I'll show you how that happens. That's how we deal with it from a traditional IT standpoint. If the word employee starts showing up in column 3, it's not talking about the inventory. It's talking about, what's column 3 describing now? What is it? It's the location is the word I was looking for, location. So it's the employee's location. The employee's location is not the employee, is an inventory. Does the employee's location have a latitude and longitude? Yeah, you better believe it. Okay, so that you're talking about the location. You're not talking about the employee. You're talking about the location of the employee, which is something different. It shows up in column 4. Typically, it might be a work product. It may be a responsibility. You know, Court used the illustration that alerted me to this issue. But you know, an employee has responsibility for producing one kind of work product, but a contractor has a responsibility for producing a different kind of a work product. So it could be a role. An employee could be a role. And in column 4, the roles, I think that, you know, in the U.S. we have standard industrial classification, SIC codes. You know, there's thousands of these SIC codes, and you know, the IRS that's where you find it in the IRS. They define every role known to humankind and what the work products are. You know, they tell you this is a salesman. They produce orders. They do this. They do that. I mean, it's very well defined. So you can probably go out to the SIC code and find the exhaustive list of all the roles and what work products they produce. And in column 4, you know, the question is, did the person who has the role actually produce the work product? If the work product is, they have to populate a screen and say, enter. The question is, did they populate the screen and say, enter? You know, the data that populates the screen may be coming from over here someplace that populates some screen, but did the role actually do the work? So this is where the performance, management comes into it. So if the word employee shows up over here, it might be a work product. I can't think of an example. Maybe it's a role, but you know, I'm just saying it's a possibility it shows up any place. If the word if it shows up in column 5, well, we're talking about time there, so it has to be something to do related to time. It would be the employee cycle. You survey the labor pool, you offer them a job, you hire them, you classify them, you assign them to responsibility, you evaluate their performance, and you send them a paycheck, and then you retire them. Okay, there's the employee cycle. So if the word shows up, if it is relevant to column 5, it had to be something that had to do with time, so it'll be the employee cycle. If it shows up in column 6, it had to be some kind of state. You want to increase the state of some employees or something. It would have to be an end or a means. Ends or means are the meta model in column 4. So in column 1, it's things and counts, inventories and counts. In column 2, it's process inputs or outputs. In column 3, it's nodes and connections. In column 4, it's roles and work products. In column 5, it's points in time and lengths of time. I was taking the employee cycle. There's a point in time you offer them a job. There's a point in time you hire them. There's a point in time you assign them. There's a point in time he reports the work. There's a point in time you send them a paycheck. Those are the events in the time cycle. So it's points in time and lengths of time in column 5, and then it's ends and means. An end is a state change, and means is the strategy used to change the state. And I'll talk to you about this a little bit later. The rules are embedded in the strategies. And when you have a conflict of objectives, say, we got to grow here. We got to optimize. So, wait a minute, Chief. You want to grow or do you want to optimize? There's a conflict. So under certain conditions, we want to grow. Some things you want to grow, but other things we don't. Okay, there's a rule. Under some conditions, you want to increase employees. Under other conditions, you don't want to. So the rules are embedded in your alternative, your strategies to change the state of something, and we'll talk about that some more later. I'm just saying. What's normalized is not the words. What's normalized is the meaning. Okay, so yeah, when you read through the document, you're going to find employee. You say, wait a minute, is that an inventory or is that a location or is that then you had to know the context. Oh, wait a minute, this is an inventory. So the answer, would all the words have the same meaning? The answer is no. Here it's an employee inventory. Here's an employee input or output. Here's employee location, employee responsibility, employee cycle, employee objective. So the meaning changes, basically. And the column defines the context for the word. Now, by the same token, here, if for some reason the same word shows up more than one primitive model in a column, would they all have the same meaning? I'm looking at just column 1, employee inventory. Row 1 is red, right? Row 2 is orange. Row 3 is yellow. If employees start showing up in more than one place, does it have the same meaning? And the answer again is no. Okay, if you're the employee scope, you're just basically identifying the requirement to manage some inventory called employee. In row 2, it's the employee concept. Here, I can probably show you this is a good idea. In row 2, it's the employee concept. Now, when the owners of the enterprise here, business management, when they say the word employee, what they're thinking about are these kind of things. Employee, what employee, right? What they're not thinking about is a record called employee. That's a representation. That is different. The employee is one thing. The record of the employee is a completely different thing. Okay? Court was in the Navy too. He was on an aircraft carrier, and he talks about I would have called him the chief yeoman. They changed the names on me here. I was in the Navy so long ago, back in, Admiral Nelson and I. No. It was Trafalgar, in case any of you guys. Anyway, the yeoman, who is the administrative guy, works in the ship's office, okay? The yeoman is talking at court, and he said, I've been on this ship for 5 years, and I have never been on the flight deck. As far as I'm concerned, all those airplanes are sitting right there in drawer 2 of the file cabinet. Okay, the airplane to him is a record, it's a file folder. It is not the airplane. The airplane, that's two different things. Okay, so here you're defining the filing system, that's in the file cabinet. And here you're defining the inventories as they exist, the concept of the inventories. You see, and these people up here, what they care about are, you know, when can you put something into inventory, when can you take it out? Before you hire an employee, do you have to have a position to put them in? Yes. Are you going to accept orders for products before you have them in stock? Yes. No. Yes. They're defining the inventory policies. That's the way they control the assets, by the way. That was the way IBM, years ago in the 50s time frame, the VP of DP, the data processing, he had a staff. He had plans and controls and data process and network. Those are the staff that worked for him. The controls guy, the way they controlled DP was controlling the inventories. When can you put a machine into inventory and when can you take it out? Okay, that's the way they control the assets. It's an asset management issue. Okay, nothing changed actually. So that's what these people care about. These people up here could care less about the filing system. They don't care about the filing system. That's why I hired you. You tell me what the filing system is. So the filing system has to support the intent these people have. In the filing system, if the rule is you can't hire an employee unless they have a position to put them in, you can't put a record in the file folder until there is another record in a different file folder. That's what's going on here. You understand what's happening here? This is the filing system, and this is the business policies that govern the inventories. Those are two different things. But this has to support that. If this does not support that, you have an asset control problem down here. So you got two different things here. Okay, you got the filing system and you got the business policies. And those are two completely different things. Okay, so, and interestingly enough, these guys could care less about that. They don't care about it, except when they want to know how many airplanes they are. If you don't have the right number of airplanes in the filing system, that's the white collar system, they don't control the inventories. So, yeah, you understand what's going on here. There's nothing magic going on, but these are two completely different things. And so these guys, that's the filing system. These guys could care less about the filing system, except insofar as going to affect how they store the data actually, whether they're going to put it in a file folder, whether they're going to put it in a table, or going to put it in a segment, or you put it in a flat file, or put it in a XYZ, an object or something. That's what they care about. They don't really care about this, except as it's going to affect how they store the data. Okay, now the reason why these guys care about where they store the data, they have to be careful about the performance of the technology. When you say, send me the employee file, or how many employees are there, if it takes an hour to respond to that, these guys are in trouble. They got to make sure that they're putting the data in places where it reduces the time it takes them to respond from a technical standpoint. So these people are optimizing this to support that. These people have to support that, but they're optimizing it for the technology performance. Those are two completely different things. These guys have to make sure that whatever they're keeping the data about, whatever the logic records are, is supporting whatever the business policies are. These guys have to make sure that whatever the technical performance is fast enough or adequate enough or whatever to support whatever management, when they have to respond to delivering views of the data or what. So these are two completely different representations. I heard Karen Lopez, really a good friend, she lives here. She's the logical data modeling lady, and she was having at a conference, having an argument with Mike, somebody, I don't know Mike, but some guy named Mike. He's a DBA. She's the data administrator, he's the DBA. And Karen is saying, I got to have nulls in, is adding attributes to the file count because, null means just a yes or no, or it's on or off, or it's a flag or whatever else. And Mike is saying, no way, I don't want to see nulls in anything. Forget that. See? Now, Mike is saying this because I don't know how I'm not technical enough to know why, but he is saying that affects my performance. And they had about 6 or 7 things they were arguing. Karen is saying, I want this, and Mike is saying, no way, I want that. So they were demonstrating the complete difference of the way you structure these things. Yeah, okay, so then down here, you're going to have some, this is the Oracle 9i standard. So you got to say, when I see a table, it's going to have this kind of characteristic, and I see an attribute, it's going to be a column in the table, and that's the way I'm going to find that actually down there when I get it on a device someplace or other. So, Oracle 9i standard is one thing, DB2 standard is a different thing, Access standard is a different thing, SQL 7 standard is a different thing. So, in order for the vendor tool to find the actual, here's an employee 100111010. That is Paul. Okay, 101110 is Robin. Okay. They got to go find Paul or Robin or whoever, Morality or Snell, or forgive me, you guys. I forgot that you guys were online. Anyway, forgive me. So yeah, that's how the tool finds the actual record. The digital expression of it on a hardware device someplace or other. So all these models are different. This is a model of the concepts, business concepts. This is the model of the records, how you're going to store the data. This is a model of how the physical storage device, how you're going to, where you're going to store it. This is the vendor expression of how you're going to find the data when it's actually, in the technology, and that's the actual data. Okay, so they're all different. Are you guys all right? Sunil, you're looking at me and say,
Yeah, it's too much, but it's okay.
okay.
So you brought up the metric. If I'm the business person and I want something in an hour, that would go in the when column, right?
Well, yeah, now we're talking about, for some reason, they want to be whatever the cycle time is over here. That's going to affect maybe the way you do something over here. There's a relationship. See, here, if you go back to the parts, when I was talking about, these are basically the part structures. You have a part has functionality in some location, operated by somebody at some point in time for some reason. There is the composite, okay? So you have a record is processed by some process in some location by some role at some point in time for some reason. So you got exactly the same thing. Across every row, there's an integration across the row. And the little gray lines on your framework graphic, they're not specific, they're just artistic, saying there is a relationship between this and that, and a relationship between this and that, and there is a relationship. That's all it's saying. Those are the composites. Yeah, Marley.
Maybe come later phase. Just have a question. Is that the column 1, when you choose the technology, it also depends on the column 2, 3, 4. So, because when I take an individual entity, it's a simple entity, so I can go, my technology is ABC. But when I go combined as a picture, it may not support. So, will you explain later that part? Or?
Yeah, now this is a really important issue, okay? And I typically, a lot of times people don't even ask the question, but you can see how somebody could spend a lifetime knowing how to do this, okay? Because there's some things that making that a good model, and there's some things that are making it a not good model. Now, Mike is saying, I don't want to see nulls. I want to see this or that. He had 4 or 5. I don't remember what they were, but you know, you can spend a lifetime figuring out there's something that's making it good and something that's making it bad, you know. There's some ways to do this, you know, performance is going to poor and some are going to be good. But you also have to know, you know, if you can spend a lifetime, but you also have to know how you structure this to accommodate the requirement for that, okay? And you also know what are the implications down here. You don't have to be an expert up here and down there, but you have to know enough about it that you can negotiate. He's negotiating with Karen. And Karen's saying, I want this, and he's saying, I don't want that. So, you know, in order to define this, you have to know there's something about something up here and something about something down there. By the way, there's a negotiation taking place here. If you want something over here, it's going to affect this, or here, 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 or there. It's going to affect that. So you have to know enough about what's going on over there because you're going to negotiate. Hey, this guy over here is saying, I want this, and this guy said, hey, the cost of that is so high, you don't want to do it. So you understand what's happening. By the way, now you know what I think is going to be the set of specializations as we see the maturity of enterprise architects get better. You can see where I think the specialization is going to be. You could spend a lifetime in any one cell. And because you have to know not only that cell, what's making it good or bad, but you have to know how it supports that and how it transforms to this. And you have to know how to negotiate across the row. And if you don't negotiate, think about this. If you don't know this, you make a wrong decision and you get down here and the performance isn't working. And people don't use the system you just spent however many $billion making. In fact, Chris Loosely was a guy that defined the performance. IBM had a research project in Santa Teresa lab, System R it was called, and they had a software that would execute Ted Codd's relational model. It was called System R. But the performance was dismal. And management was saying, look, this will never be a commercial product. Nobody will ever buy this product. The performance is so bad. No, even though it's managing relational, a relational model, has set theory, and you can normalize everything, they aren't going to buy this thing. So they were going to terminate the project. And Chris Loosely was the guy they imported from England. Actually, they imported the 3 Chris's from the Hursley lab in London, or outside of London. Chris Date. Chris Date was the guy who interpreted Ted Codd to the rest of humanity. Ted Codd spoke in mathematics, okay? And people would say, what'd he say? You know? And Chris Date would say, well, this is what he said. Oh, well, that's pretty good, you know? So he was interpreting Ted Codd. Ted Codd was virtually unintelligible. You know? Anyway, so I was going to digress. I'll just leave it at that. You know, but Chris Gain was the process modeling guy. You know, in Europe, Gain and Sarson were the structured methods. In the U.S., it was Jordan DeMarco. You know, Tom DeMarco defined the process modeling. That was here, okay? It was Chris Gain and Chris Sarson. I didn't know her. She was a lady, but I didn't know her. But Chris Gain was the process guy. Chris Loosely was the performance guy, okay? And Chris wrote a book, High Performance Client Server. And he didn't like the title of the book. The publisher defined the title of the book. But in the book, he described every combination of things where you could distribute things. High performance client server. Mainframes are bad. You know, distributed processing is really good. Okay. Okay, so I'm not, you know, anyway, that was a silver bullet, right? You know, the logic of it wasn't necessarily valid, but everybody thought, okay, we get rid of all the mainframes, we just put it out on servers someplace or other. That fixed the problem, right? Wrong. Okay, it didn't fit, it made it more complicated. So Chris wrote this book. See, you can put the screen format outboard, but you can keep the processing and the data inboard. Or you could put the data outboard and keep the screen format and the processing inboard. Or you could have a data server. Or you could put an application server, put the process outboard, keep the data in the inboard and the screen format inboard. Or you could put the data and the screen format outboard to keep the process inboard. Or you could put the process outboard to keep the, you know, there's a whole bunch of different combinations about these things. So Chris Loosely basically said, you have to, he was using my framework in this book, you have to understand this up here and know what that is, basically, before you get down here and write the code, okay? If you don't know what this is, and you don't know how to transform this to this, that, you're going to build an implementation that is not won't perform. Nobody will use it, see? Because the performance depends on where you put things. If you put the data outboard, and you want to get the data, you got to have a transaction that goes out, finds the data, read through all the rows in the tables, pick the one out you want, and move it back to where you got to get to it and put it in a screen format. That takes time. Okay? So if you put the data out there in the wrong place, you know, your performance is going to be dismal. You have to know something about the enterprise up here before you start deciding where to put things. If you let the programmer who's writing code down here decide which data they're going to put in which location and what the address of that data is, and his address is someplace outboard or address is inboard, and then you got all the performance implications of remote devices where you're storing the data versus processing the data in machines, you know, processor speeds. It's complicated, okay? So he wrote this book, and the whole thing, performance, is all dependent upon where you put things. Okay, that's the point. So the same thing happens inside the machine as happens outside the machine. If you're putting the thing, it all depends on where you're putting it inside the machine. So what Chris Loosely did is he wrote the performance algorithms for the converted converted system R into DB2. And then the performance was okay, and they commercialized it. Okay, you guys, Carter's really getting nervous, which forgive me, I got, you know, digressing again, but I'm going to turn this over to Court, and I'm going to get out of his hair in a minute. So I want to show you, I don't know why this should be a build here, but here is a primitive model. I'm just trying to say, here's customer, and here's an order, you know, and here's the count. A customer could have many orders. An order has to have only one customer. And that would be a primitive. Here's an entity and a count. Oh, by the way, there's an entity on the other side. So therefore, but this is a primitive. Now, that is different from, here's a composite. As soon as you put a verb on this line, that's a verb. Where does verbs show up in the ontological structure? Is it in column 1? Column 2. So now you have something in column 1 and column 2 in the same picture. And by the way, here's an optionality, here's a mandatory symbol. Those are rules, basically. Ron Roth would say this is a rule, mandatory. You have to do it this way. Anything that constrains your behavior is a rule. This just is optionality, which says it's not really a rule. It's just saying you have an option to do it, doing more than one thing. So, but these are coming out of column 6 someplace or other. Under some conditions, you must have a customer before you accept an order. Okay, so there's the rule. So this down here is a composite where this is a primitive. Okay, now think about this for a minute. This is hard because the tool will force you to do this. And as soon as you put something from column 2 and column 6 on the column 1 structure, you've created an implementation composite. That's what you need for implementation, because this word tells you what the attribution is you need on customer or on order or both. So that's why they force you to put the verb on there. But as soon as you put a column 2 thing onto column 1, you've created a composite. So what you want to do is you want to leave places over here in column 2 and have a foreign key in the the transformation table and point it to this relationship, and then you can put any verb you want to on there. Is that the only verb that goes on between the customers' orders? No. Customers place orders, customers change orders, customers cancel orders, customers validate orders, customers do a whole bunch of things orders. If you're building a data model, a data model, you'd have to have customer place orders, customers change orders, customers cancel orders, customers validate orders. In order to build the model, you have to have more than one line. Hey, forget that. Just keep places, cancels, changes over here in column 2 and put a foreign key. This places goes on that line, changes goes on that line, whatever. You reuse the process onto the line. You could create the composite by, loosely coupling the variables together.
John, I'm confused. Is this rectangle just you created for us to understand, or is it maybe because confusion is the how? When we talk how, it should be in a kind of a circle, or that's. I'm sorry, I might miss this.
The how changes independently of the what. Here's the what. The how is sitting over here in column 2. And, places, cancels, changes, all the hows are sitting over there. This changes independently of the bill of materials. In a bill of materials, you find no expression of functionality. In the IT system, you embed functionality in the process. Or you embed it in the structure, in the data structure. So, we don't design for change. We design for implementation. So you hard bind things together. You put the verb right and the rules, column 6, right in the same, in the same table. Okay. In fact, the way you write the code, the languages are designed to you embed the data in the process. By the way, there was a time when they built a compiler. You keep the data. You had the data division and you have the process or the process division. You'd separate them. Okay, so if you want to change one data element, you can change the data element, but every process every instruction to use that change data element uses change data element. You change one instruction, all the data used by the change instruction, used by the change instruction. So if you don't change anything, you separate the independent variables. I'm describing COBOL, by the way. I mean, I don't know. Some of you guys may.
If I take out the places from the variable, is it a composite or is primitive?
Say, no, well, you put places goes over here in column 2. So here's all the instructions that are sitting over here. Here's all the data that's sitting forget about this. All the data is sitting over here. You have two different things. You have the data, here's the procedure division, and here's the data division. So you got two different things. You can do something over here, and you reuse it over there. Do something over here, reuse it over there. So you can accommodate any composite that you want. Here's the example. Here's the primitive. Here's the data structure, customers place orders. Here's the process, place orders, change orders, cancel orders, and, oh, wait a minute, here is you have to have the rule that says we have to have a customer before you can accept an order. Okay, that's the rule over here. So here is one primitive, here is a different primitive, and here is a different primitive. But I got them all separated here. So then I could say, click, give me a picture, a model. Say, click out of my repository. Oh, there's the model. Okay, I can create any composite I want. If I just have you have a loosely coupled in the repository table. You have a foreign key that goes from the strategy to the inventory, or to the process, or to whatever you want. I can connect up anything that I want. Okay, is the computer program tear that piece of paper up and create a different piece of paper? Computer programs. Are computer programs printers or composites? Composites. Are computer programs engineering ideas or manufacturing ideas? The computer programs are composites, those are manufacturing ideas. Are computer programs architecture concepts or implementation concepts? Implementation. Are computer programs good or bad? Wait a minute, that is the wrong question. Okay, that is the wrong question. That's not a matter of it. The question is, how did you get the computer program? That's the question. I mean, did you just write the program in order to get the code to run? You've heard of that probably. You just write the program to get the code to run, or did you assemble, late bind the program from architected, integrated enterprise primitive components? If I got all these things separated and I have their integration, connected, loosely coupled, I can create any computer program I want. Click. If I want to change the address of a data element, I just change the foreign key, click. If I want to change the picture, click. Yeah, would that be helpful? Well, yeah, it'd be really helpful. But that implies somebody figured out, what are the single variables and put them in the repository, separated them, and connected them just by loosely coupling them together, defining them, integrating them with a foreign key in a repository table. Now you got another thing here. I was trying to differentiate the depth and width of a cell. This would imply enterprise-wide at excruciating level of detail. This would apply enterprise-wide at a medium level of detail, enterprise-wide at a high level of detail. This would apply over here. This would be a sliver of the enterprise, not only a portion of the enterprise. This would be half of the enterprise. This would be enterprise-wide. Okay, so I mean, you got those variables you can embed in here conceptually that just help you think about this. And anything that you do not define, you're allowing anybody and everybody to make assumptions about it, okay? If you don't define the detail here, you're allowing anybody and everybody to make assumptions.
One more question. So, technician perspective, this is the one where the program goes, this we are telling composite. What happens to, like, see, if I take like row 5 and column, this column 2, okay?
Yeah.
Yeah, this is a composite. So this depends on the row 4. In that case, row 4 is like a primitive or it's a composite?
Well, what this is telling you what this is the structured methods, a structure chart. Here, this is a module that, has that transaction in it. This down here is the instruction in COBOL or Fortran or Java 2 or XY. Here's all the instructions down here. This is telling you what the inputs and outputs of the process. You have instructions here that are telling you what the inputs and outputs of the process. And in fact, you're reusing some data element as an input or output of some instruction over here. But you're just separating out all the independent variables. That's what's different about architecture than what we typically do. That's why it's, that's why I'm saying that's where it's hard for us because we don't think in these terms. But in fact, we did at one time. Here's the procedure division. There's the data division of COBOL. They actually, the tool and the vendor tool just separated it for you. And why'd they do that? Because it's good for change. Okay. And then we got rid of COBOL. Well, COBOL takes too long, it costs too much, or whatever. They had a new compiler, TL1. Did they have the data division, the procedure division? No, you just embed the data in the procedure. You put it in there. By the way, you start putting other things in the code. You could put constants in there, and you could put rules in there. And then if you ever want to change the rule or change the constant, you got to go look for it and find it if you can find it. And then you have to throw the thing away and start over again. Okay, so we're not designing for change. We're designing for implementation. We're manufacturing. We're not doing engineering. Now, the one thing is once you understand this, the tools are not helping us in a lot of cases. Your compilers are not helping us because they're designed to get the code running. They're not designed for change or designed for architectural reasons. But once you understand this, now you can. Sometimes you're just going to have to use the tool like it's used, but you understand what the problem is. You try to mitigate the impact of the problem. Or sometimes you can make the tool behave like you want it to behave. Is that all right, Court? I mean, did I say that okay? Here I just was saying, you know, here is a model. It's a row 2 model. It's half of the enterprise excruciating level of detail. It's a primitive because it's all coming from one cell. Here's enterprise-wide at a medium level of detail. That's a primitive too because it's coming from one cell. It's not complete, not in. Here's one that's enterprise-wide at excruciating level of detail. It's a primitive coming from one cell. Here is a composite because you have data in there and instructions in there. It's a composite. Okay, here is a diagonal composite. You have something from this cell, some concepts, you know, in distribution concepts, and some timing, technology timing in the same picture. That is a composite because you got some from more than one cell. If you're going to do that, what I would do is I would define the relationship between this and that, you know, because there is a logic relationship between that, and this gets transformed to that and transformed to that, so I know what that is, and then I can infer any diagonal that I want to infer. So the ontological structure takes you to horizontal and vertical, you know, logic, and then you can create any transient composite that you want to create. You can infer the diagonals. Here is a vertical composite. I keep forgetting why you might want to do that. Court always has to give me the example. Why do I?
Requirements traceability.
Traceability. Yeah, if I want to trace, you know, I made this in column 1, 2, and 3. If I want to trace what's happening here to what's happening up here, you know, I can put these, you know, I got traceability that goes. I can trace where it's going to affect the change. Okay, so in any case, I'm just saying the primitives and composites, if it's coming from one cell, it's a primitive. If it's more than one cell, it is a composite. And it's not either primitives or composites, it's an and thing. You need primitives and composites. That was what the idea about the grayed outlines on the framework graphic. I don't have to talk about this. This is just saying you can do this little by little over some period of time. I'm not going to read through that for you. This is kind of important, but I'll talk to you about that later on. Here, the reason why you want the primitives. I'll give you an example, and then I'll look at it later. First of all, you can have enterprise-wide models. Okay, if you only have one thing in a model, you can see all those things in the whole enterprise. You're only looking at one kind of thing. If you put inventories and process and locations and people and timing and on one picture, that picture is going to be so complicated you'll never know what's in there. You know, you'd have to make that picture so abstract. You say, well, you can have lightning bolts and airplanes and people shooting things on one picture, okay? But it's so abstract. How do you get from there down to row 6, which is 1, 1, 0, 0, and 1, 1, 0, 0, and 0? You know, there's no way you can identify the traceability. You can't see, you know, the transformation easily. So if you put a whole bunch of different kinds of things on the same picture, it's going to be pretty abstract. And therefore, you got an alignment issue. So if you only have one thing in the picture, I'm only looking at inventories. Okay, now I can see where an inventory is reoccurring. Okay, and I can normalize it. If I only see processes in the picture, now I can normalize it. I can see all the processes, the whole enterprise. I can have them in a structure. You'll see that kind of thing in the exercise today, in fact. If I only have locations, then I can see all the locations. But as soon as I put inventories and processes and locations in the same picture, man, you can't. It'll be so. There's so many things in a picture. Which is what? It's unusable. So I'm saying, here is the elegance of a primitive model. You can see enterprise-wide models. Only one kind of thing in the enterprise model reduces the complexity immeasurably, and the model can be tested for completion. Do I have all the processes? Do I have all the inventories? That's the kind of thing you'd like to know from an architecture standpoint. Okay, guys, I'm not going to do any more. You get the sense of what I'm saying here. All right, I'm turning it over to Court. I blew out an hour. I was going to do this in 30 minutes.
You realize it's Thursday, right? We got here.
No, it's Wednesday.
Yeah, but it's Thursday. You didn't blow out an hour, you blew out like a whole day. It's tomorrow.
We've only been here.
I know, I'm messing with you, man.
Oh, yeah, okay. I thought.
All right, let's go ahead. I've got.
I'm having a senior moment.
I've got 9:30 Eastern Standard Time. So let's go here in the U.S. So let's. So the reason why I always say Eastern Standard Time or daylight time and everything is I was formally educated and schooled by Australians. So we're in Australia and we're talking with them and everything, and I'm talking about Eastern Standard Time. And one of the ladies that we're with, she goes, you know, Australia has an east and a west coast, and we're every bit as big as the United States.
If not bigger.
I said, yeah, bigger. And I turned around and I was like, very fair point. So now I've become much more sensitive to geographic location. So nonetheless, I have 9:30 Eastern Standard Time here in the U.S. So let's take 10 minutes. So we'll start back up here at 9:40. We're actually going to pick up with that exercise, that one document. You'll also want a copy of the framework out in front of you. And then I will be using the slide presentation, Introduction to Primitive Modeling. For those of you who may be watching the live stream, we'll be taking that off the air here for now, and we'll return with John later in the day. All right, and for you online folks in the classroom, just ignore that. All right, break this part we go, stretch, otherwise he'll start again.
I have a few more slides, you know.